All right. So let's look at an application of some of the stuff we've talked about with integration. Well, really one thing that we've talked about, um, which is, integration gave sort of the area underneath a curve. Well, what if we wanted the area between two curves? So let's say we had something like f of, oops, I wanted that to be back there. Let's say we had something like, f of x. Let's say this is greater than or equal to g of x on the interval from a to b. Okay? Let's say we have something like this, and then our picture there would look something like this here. All right, so if f of x is always greater than g of x, say f would be up top here somewhere. And let's use some green for g here. Right? And then maybe this is g of x. Right? Now, the important thing to care about is I'm only interested in the interval a to b, so I don't care if they cross outside. That's not really of importance here. So here's a, and here's, well, it was almost b. Let's do that. Right? So between a and b here, f is always on top, g is always on the bottom. What I want to ask about is, well, how do we find this area in here? This area A. Right? How do we compute that? Well, one thing we could do is, let's see if I can copy this, and oh, all right, well, it was working. Okay. Interesting. So I want to duplicate that. And let's duplicate it one more time. All right. So we'll see what we want to do here. So to compute that area, wow, it's like missing a whole bunch of stuff. All right, interesting. Okay. Anyway, sorry, was not expecting all that. Okay, sorry about that. All right, so how can we compute this area A? Well, to compute this, we can compute the area underneath everything, underneath the blue curve, so that whole area there, and then subtract this extra bit. So if we call this whole area here B, and this little area C, right? If we look at these shapes like that, then I'll just make a note here. A is going to be B minus C. Right? Hopefully that kind of makes sense. So, given that idea, this area that we want to compute between F and G is, right? So say A, this is the integral from A to B of f of x dx minus the integral from a to b of g of x dx. Right? And of course, we can just combine these together and write down this statement. Right? We don't need to compute two separate integrals here. We can just use the property of integrals and combine that into one. Right? So provided that we're integrating, again, provided that f of x is greater than or equal to g of x on this interval from a to b, then the area between the two functions is just the integral of the difference. Right? So just a little reminder here that f is the top function and g is the bottom function. Right? So that's the idea behind it. And then let's do a quick example. Right? So let's say we want to find, okay, so find the area bounded by y equals x squared plus 2, y equals negative x, and x equals 0. Oh, x equals 0 and x equals 1. All right, so we want to find the area between these two, that's bounded by these graphs. Right, so let's graph all these things. Oops. So let's see here. Let's see. So 1, 2, 3, 5, 6, 2, 1, 2. So let's see how much area we really need here. Right. So y equals x squared plus 2 is this graph here. Oops. Should go up there. Right, so this is y equals x squared plus 2. Right, let's do y equals x, or y equals negative x. Okay, so that's going to be here. I don't know why I drew this picture so zoomed out, actually. Because here we're going to graph x equals... No, don't do that. Damn it. This is x equals 0. And this is x equals 1. So I really should have zoomed in a bit more. So we're looking at this area right in here. Right, we want to compute the area of that region. So all we have to do is integrate over this region. In this case, it's from 0 to 1. And we just do top minus bottom. Right, so the area is the integral, in this case from 0 to 1, of, let's say, the top function, x squared plus 2, minus the bottom function, negative x dx. So if we go ahead and simplify this, x squared plus x plus 2 dx, this is going to give us 1/3 x cubed plus 1/2 x squared plus 2x from 0 to 1. And after we plug all this stuff in, we're going to get 1/3 plus 1/2 plus 2, which is, let's see here. This is 2 5/6, 17/6. That'll simplify too. Right, and that's the area between these two curves. Right? So we'll look at another example in the next video.